In this module, we will talk about again the agitator design and its operation. As we have discussed in our previous module about the radial flow impellers, but in this module we will focus upon Rushton turbine impellers. Actually, the Rushton turbine impellers are just like the radial flow impellers, because mostly there is a small difference. So mostly in fermenters, they are fabricated and designed with Rushton turbine impellers. So as you see here, as we have already discussed in our previous module, because radial flow impellers are mostly used when we need a high shear effect, when there is need to have more rupturing of the air bubbles, and that is mostly in case of bacterial fermentations. But in Rushton turbine impellers, the blades number can be varied. That can be varied from 4 to 6. Some Rushton turbine impellers have 4 blades and some have 6 blades. The point here, which we have already discussed while talking about the geometrical ratio of single impeller or a multi-impellers, that the ratio between the Rushton turbine impeller width toward the diameter of the fermenter is 0.33. But you can directly see here that 1/3 of the total diameter of the fermenter should be the width or the impeller space. So the radial flow impellers and the Rushton turbine impellers are mostly used when we need a high mass transfer in terms of oxygen solubility and oxygen need. So that is about that I have already talked about the width of the impeller in case of the Rushton turbine impellers. So a Rushton turbine is often referred to as a disc turbine too. So the disc design ensures that most of the impellers, because that need a more power. So the motor which is fixed to the shaft which rotate the impellers, that need a more power, because the most of the power utilized at the tip of the agitator in radial flow impellers. So that's why, as concerned the maximizing the energy use for the bubble shearing. So in case of this, you can see in this diagram or a picture that how the disc turbine, or we can say the Rushton turbine impellers, so when they move, that most of the energy, because there is a more resistant of the fermentation media in the path of the impellers when that will move. So that's why, as we have already discussed about that, when we use the radial flow impellers, or in other words we can say that Rushton turbine impellers are a disc turbine impellers that require more energy consumption. But that energy consumption is mostly used to rupture the air bubbles. So if there will be a more resistance to that, then there will be a more shear of that. So that's why in case of radial flow impellers, then that is the maximum effort to convert that power into creating a more shear effect in radial flow impellers while working in a fermentation vessel.